This chapter is rather long. We will go through many aspects of climate impacts on food production, food security, food safety and nutrition, food utilization, price stability, and various mitigative efforts or strategies that are able to reduce the impact of food on health in many ways. Okay, so let's go through it systematically. I think the chapter comes off as a bit of a little kitchen sink, but nonetheless all the points are important. And I'm going to skip some like pesticide residues and so on. Nonetheless, there is a lot of material that's very relevant. Okay, this is an image from the IPCC AR5, the last report that came out in 2014, which basically summarized all the evidences here with confidence levels going from very low to very high, shown with these stripes and histograms. And the systems considered are physical systems, so glaciers, snow, ice and or permafrost, rivers, lakes, floods and droughts, coastal erosion and or sea level effects, and biological systems, terrestrial ecosystems, wildfire, marine ecosystems, and human and managed systems, which include food production, livelihoods, health and or economics. Okay, so there are other symbols here, minor contributions of climate change, and filled symbols represent major contributions of climate change with regional scale impact. So the main message you get out of this is that all continents, including Antarctica and the Arctic, are impacted in essentially all systems, physical, biological, human and managed systems. And there are many regions where our confidence based on evidence, peer-reviewed literature and past data, trends and so on is very high. Some have lower confidence, like here fisheries, for example. And terrestrial ecosystems, and there are places where the contributions from climate change are major and there are places where they are minor. Okay, other than that, I don't want to say too much. That human footprint is now on every system, on every continent and all the oceans, including the polar oceans and the Antarctic continent, right? Looking at a little bit more here, distribution change in kilometers per decade. So as you warm the system, you expect change in species distributions, like butterflies moving to higher latitudes, or ecosystems climbing up to higher altitudes, and so on and so forth. And the numbers here are various indicators of number of studies that have been found and so on and so forth. So the range of things here: benthic algae, benthic cnidarians, benthic mollusks, crustaceans, invertebrates, phytoplankton, zooplankton, bony fish, non-bony fish, and so on and so forth. This is altogether all taxa. And the main thing we'll focus here on, other than the marine fisheries and aquaculture, which we'll come back to, is the impact on yield in terms of percentage change per decade. Again, number of studies here doing projections with this range being shown as the median and 95th percentile to 10th percentile. So here you have tropical and temperate regions, and crops considered are wheat, soy, rice and maize. So you can see that there is basically other than soy, everybody else is having a negative impact yield change in by region or by crop. Okay, soy is somehow a robust one against the climate impacts, but this depends on whether the plant is a C3 type or a C4 type, which we mentioned briefly before. C3 are wheat and rice, for example. C4 are many of the newer species which have a different pathway and respond differently to changing temperatures and carbon dioxide levels. We have already seen how carbon dioxide affects plant responses and how that translates to various health outcomes, right? So broadly speaking, the impact of climate change on the food industry can be seen here from Foodware 365 website. Agri-food damage production, so crop and agriculture are susceptible to temperature changes. Crop growth lacking in nutrients, we will see a little bit more of that. Rainfall and irrigation heavily influence crop growth. Radiation damage to biolife, so UV radiation damaging both plants and livestock. Bread and bakery with less nutrition. Pest impact on agriculture, so warming, humidity, rainfall, etc. affect pests, plus application of pesticides, pesticide efficacies, water pollution, impact on crops itself. Bee colonies are decreasing, not exactly well understood, but it's a misbalancing of a natural cycle. Crop yields are devastated. Changes in crop yields need to adapt to climate conditions, so there are issues of crop choices and approaches like agroforestry, which reduce the damage of winds and floods and soil erosion and soil nutrient loss and so on, for example. Hurting seafood population, warmer, more acidic oceans impacting fish population. We'll see a little bit more of that. Environmental effect of meat. So we will look at how agriculture itself affects the environment. Feeding people has become a climate consequence now. So agriculture is now a major contributor to environmental damage and greenhouse gases. Decimating forests for sugar. Palm oil and sugarcane as climate change culprits. So this is especially bad in some parts of Indonesia, for example. So cash crops plus bioenergy are driving food security and environmental degradation, forest loss, land degradation, and so on. This is another example of the same thing we already saw, looking more at time horizons. So here we are with yield losses negative, all of them here. So in this case, soybean is negative out to the future, 2030 and 2050. So 2050 is greater, especially for rice. Also for maize, wheat, and on average for all the crops. Okay, so we'll come back and look at some of the definitions of food security, food utilization, and eventually get into how that affects health, but mostly point to pathways through which climate change is manifest in the food system, food security, food safety, and food utilization, as well as nutrition, which obviously will translate to health outcomes, right? Not positive, of course.